All right. So, hello, students. This online lesson will serve as kind of a review for your final exam. The final exam will be on Wednesday, February 25th at 8:15 a.m. So, it's going to be your first exam for that morning. And I will go over every type of question that's going to be on the exam, what materials I would study if I wanted to pass, and if we have time at the end. I know that there is also graphing quadratic formulas that is not on my exam, but is part of supplemental math for Mr. Dong Wang's class. And I think we'll be able to go over everything that's going to be on the exam fairly quickly. And I would like to give you some tips and tricks on how to graph quadratic equations for that class as well. So I'm just going to jump right into it. I know I have some notes in front of me of the study guide and some stuff that would be on the exam. And I'll just go through it very quickly. So I'm going to open up the whiteboard. And I know that this whiteboard, my handwriting is going to be very bad on it. So that is all right. But we will do our best, right? So the first thing that I would like to go over is mean, median, mode, and range. Okay. So if you have a data set, right? Let's say you have the numbers 5, 3, -2, 1, and 0. Okay. Mean, median, mode, and range would be the mean would be adding every single one of these numbers. So mean, okay. And this is what I mean by my spelling, or not spelling, my handwriting is going to be awful. Mean is going to be adding every single one of these numbers together. 5 plus 3 equals 8, plus a -2 is going to be a +6, plus 1 is going to be 7, plus 0 is going to be 7. So then we take the total number divided by the total numbers, unique numbers that we have. So it'd be 1, 2, 3, 4, 5, right? So 7 divided by 5, and that is going to equal 1.4 or 1 2/5, right? Either way you would like to write it, fine with me. Or if you want to write 1.4, that is also fine, right? That's mean. Median, all right, is the middle number, okay? Basically, you have to order all of these numbers, okay, in a singular, like from least to greatest. Can I change the color in here? Whoa, I can. Awesome. Is 0 the least number? No, it is not. It is not the lowest number. It would be -2. -2 would be the lowest number. You go -2, you go 0, then 1, then 3, then 5, right? From least to greatest. All right. So then after I order everything from least to greatest, I am going to then cross out, okay, the last number or the highest number and then the lowest number. Then cross out again, the highest number, then the lowest number. And I'm left with my middle number. That is going to be the median. Now, what if there is an even amount of numbers, right? Let's say just for fun, we're going to add in right here a 2, right? And so when I cross it out, now I have two middle numbers. I have 1 and then I have 2. The thing we're going to do is we're going to add 1 plus 2 equals 3 and divide by 2. So we're taking the average, the mean of those two numbers. That is going to be, sorry, that is a 3 that I'm adding. It's because I'm already doing it in my head. All right, 1 plus 2 divided by 2. That'd be 3 divided by 2. All right. Wow, this is very challenging to do on this computer. All right, that is going to be 1.5. All right, so that would be the median if there were an even amount of numbers, right? I added two into this data set. But given just the data set that I have here, median will be one, right? Let's do range next. So range, okay, if I can spell it. Range is going to be the highest number minus the lowest number. Now, there's a couple of y'all that messed this up on the test, and that's all right. But the highest number in this data set would be 5, okay? And the lowest number is -2, okay? That means that the range isn't 5 minus 2. It's 5 plus a positive 2, right? That's how we do subtraction from a positive number and a negative number. So 5 plus a positive 2, that means 7. 5 minus -2 equals 7. Okay, that would be the range. If you want to illustrate this better, the way that Mr. Ryan thinks about it is I have a number line. Right here is 5. Right here is 0. Right here is -2, right? And what the range is saying is how much space is there from the lowest number all the way to the highest number? How much space is in between there? Right? That's all the range is saying. And that would be 7, units, I guess, of space. So that's why this 7 is a bigger number than the highest number, 5, if that were to make sense to you. And then mode, let's say I added so mode in this case, right? Um, for consistency, we'll keep it black right here. Mode in this case means what number appears the most. So the mode wouldn't be 5, that's the highest number. In this data set, there actually is not a mode because there is no unique number that appears more than more than once. But let's say we were to add another number, let's add a 3, okay? Now in this data set that I've added a 3, the mode would be 3, right? Because now that I've added this new number right here, and there's 2 3s, right? That is the number that appears the most. There's going to be a few questions like this on the exam. I hope it's pretty easy points. This is something that we've learned in M1 already. And yeah, I think if you need practice with this, watch this video, do the study guide. There are definitely those two would be good practices for this. All right. Okay, knowing your definitions. Let me pull up the copy actually of the study guide. Um, I think that might be a little bit better. Okay. Knowing definitions is going to be very important. I'm just gonna briefly, is there a way to erase everything on the whiteboard, or do I have to create a new whiteboard? This is like my first time using it. Okay. New whiteboard. Yay. Awesome. Best day ever. So, knowing definitions, there are going to be a handful of questions on the test that deal with, do you know what population versus sample is? Okay. Do you know what a variable is? Do you know the definition of mean, median, mode, and range? Like, could you describe it in words? Do you know what an outlier is? Do you know what quantitative versus qualitative data? So I'm gonna take maybe a couple minutes to go over what I think would be important for the test. Definitely know mean, median, mode, and range, those definitions. Population versus sample. Okay. Think of a picture like this. The entire thing is population. Population. I could have drawn a bigger circle, but that's okay. Population. This is every single person I could possibly ask for my survey. Let's say I'm asking and I'm wondering you know, what is the favorite food of every student in Thailand, right? What's every student in Thailand's favorite food, right? The whole population would be every single student in Thailand. But obviously, I can't survey every student in Thailand. That's insane. What I can do is I can survey Assumption College and I can ask them, survey every student, and that would be my sample. And then whatever answer they would give me, and let me make this a little bigger because I don't think I can write the word sample that small. Whatever answer they give me, I would say, maybe that's a good guess on what the whole population is. In other words, let's say Kaichio is every student at Assumption College's favorite food, right? Or that's what appears the most. I can say, well, maybe for the entire population of Thailand, that's every student's favorite food. I don't know. It's one of my favorite foods. So that's what I want you to understand, okay? Think of this illustration. I mean, even if you draw this illustration, I might give you half a point, but I'm looking for you to describe this illustration in words. So I'm looking for population is the whole group that we are studying. Sample is a portion of the whole group used to represent that whole group, right? Sample is where we're extracting, where we're collecting our data from. Population is every possible person that could be sampled. Okay. If you look at the study guide, it has the definitions on the first page right there. I have also given you the tests. I've given you the Unit 6 test back, and that would be very, very good to study too. That exact question was on the Unit 6 test. Um, I'm going to drink a little bit of water because I feel like my voice is already from talking. Mm. Ooh, okay, that's better. All right, let's go. Variable. You're going to need to know what a variable is. Okay, variable is a thing that we measure. Okay, it's a thing that changes. So on the test, y'all had we surveyed 20 students on how many push-ups they could do, right? So the variable in that case would be push-ups, right? Some students did 20 push-ups in 1 minute. Another student did 15 push-ups in 1 minute. Another student did 3 push-ups in 1 minute. Another student did, 10 push-ups in 1 minute, right? And so we studied and we got, different data points for that. The thing that's changing are the push-ups. The number that what does the number represent? That is your variable. When you try to figure out a variable, just ask yourself, what does this number mean? 20 what? 15 what? 3 what? Push-ups. That's what it is. That's your variable, the thing that changes, right? Hmm. I probably really should have a glass for that. Ah, alas, I am too lazy, but not lazy enough to teach. All right. So what else would be? We have variable, we have distribution, okay? Distribution is how data is spread out, is how data looks, right? So if I have a distribute, oh my gosh, that is a terrible line. If I have a distribution, right? Right? All the data could be clumped up right here. Here's a nice, cool, pretty dot plot. Yay. Right? All the data is clumped up right here, right? So here's my distribution. I expect your dot plots on your test to be way, way better than this. But all the data is clumped up right here. It's just how is your data spread out? How does your data look? That's what distribution is. What would be this little dot right here? Does this dot seem a little weird to you? Well, it's not with the rest of the data points. So I would say that this dot is an outlier, okay? This one is an outlier. And if you can't read my spelling, well, do not worry, neither can I. Oh my gosh, the spelling is awful. Okay. OU outlier. All right. Outlier is something, if you want to get technical, it can be measured if you get further on into your statistics career. You can measure an outlier by the amount of standard deviations it is away from the rest of your data. And standard deviation is a statistic term that you do not need to worry about right now, but you should in the future. It is very, very interesting. For now, all you need to know is that an outlier is going to be further away from the rest of the group, right? It is outside, right? An outlier, right? Something that doesn't look like the normal part. I think that's everything. Oh, one more easy one. Quantitative versus qualitative, okay? Quantitative versus qualitative. I should write this down because I want y'all to remember this. Quantitative. Oh my gosh. Quantitative. This would be so much easier with an iPad. Quantitative. Please be kind and do not laugh at me struggling trying to write this. Versus qualitative. Well, this will be some comic relief. Qualitative. Okay. So quantitative is numbers, okay? Quantity. The way I remember its numbers is you see this N right here? N also has numbers, right? So the 20 push-ups, 15 push-ups, that is quantitative, okay? Qualitative would be what's your favorite food, right? A quality, something that cannot be measured on a number line, something that, is not an integer, but it is describing a feature, quality, okay? As long as you remember that, you're fine. If anything, just remember that the number one has an N, quantitative like number, and then the qualitative one would be the other one, right? So you only really need to remember quantitative and you should be good. All right. I think that's good for definitions. Um, the different plots that you need to know, okay? So we have dot plot, okay? Oh my, where did my, okay, there we went. Okay, now I'm gonna be making these look very ugly. I am restricted on how pretty I can make my graphs, so unfortunately, I have much higher expectations of you right now than I do of me. But I will be very descriptive about what I am going to expect on the exam. Okay, so dot plot, right? We got dot plot right here. I'm not gonna write the words. I am gonna write the words. Dot plot. All right. Stem and leaf plot. Okay. We got stem and leaf plot where stem would be here. Now, these are things that you're going to need to know how to do on the exam. I promise you, we're going to be doing every single one on the exam. If I were you, I would have my Unit 6 tests out that I gave y'all. I would have it out. I would look at each plot that you got right or you got wrong. And the ones that you got wrong, I would pay extra attention on what mistake you might have made and what point I might have taken off. We got frequency table. Okay. Um, So this would be like, I don't know, number, and then this would be frequency. Oh my gosh. Frequency. All right. This is the best I know how to do it right now. I'm sorry for the terrible spelling. Wow. I would give this a 40%. That's what I'd give my artistic abilities right now. Okay, and then histogram. But A for effort, right? And then histogram is going to look something like this. So I'm going to go over the common mistakes between each one, right? And we will see maybe what. Okay. So first off with dot plot, the most common mistake I would see, there's a couple mistakes. First, make sure you have a title. Your title needs to deal with something with the problem. So if I surveyed how many push-ups each M2 student can do in 1 minute, your title should be number of push-ups, right? Your title shouldn't be M2 students because that's not what the dots represent. The dots represent the amount of push-ups. Like it's, yeah, each dot is an M2 student, but the number that it's above is the number of push-ups. I need to look at the plot and see, hey, what are these numbers representing? The more specific you can be, the better. Okay. You can pretty much find a good title name just from the question. On the test, I think if you put any title, I gave you a point. I didn't take off anything. Because I think I should have been more specific in the instructions, but make your title have something to do with the data. And then when we're doing our dot plot, if you have 50 million dots like I'm creating right here, and you have more dots than data points, and it just keeps piling on, and we only surveyed like 10 students, but for some reason you have all of these dots right here, obviously you might have done something wrong. Okay. That is not how our dot plots are. I think I had some tests with a ton of dots. I don't know how we got all those dots, but each dot just represents one student above one number, right? So if this is one, this is two, this could be how many brothers and sisters do you have? Two, three, right? Four. Okay. That's dot plot. I think hopefully, oh, I skipped five. Oh my gosh, this is awful. Okay. All right. 1 through 6. That's what it should represent. Stem and leaf plot, okay? The part people got wrong here, one was not having your key. So the key in a stem and leaf plot, okay, tells us what the numbers mean, right? So if I write, 1, 2, 3, 4, okay? And here's 0, here's 1. This could be 3. This could be another 3. This could be 4. This could be 0, 8, and then this could be 2. Okay, here's our nice pretty data. Well, I don't know about pretty. So a key, right? I would write the word key, right? Not like a key for your condo, for your house, or anything like that. Okay. This is more like a roadmap. Okay. It is to tell us what do these numbers represent. So pick any number, doesn't matter. 2/3 equals, and then what does this equal? This could be measuring how many, milliliters of water are in a cup? No, is it 2.3, right? I don't know. Or is it 23, right? Or this could be measuring the populations of a city where 2.3 is actually equal to 2,300 or 2,000 or 2,300,000, right? So you have to tell me what these numbers represent. That's the most important thing for a stem and leaf plot, okay? I erased part of my leaf. Um, I believe on the test I did not take off points if you did stem or if you did leaf. As long as you got all the numbers and you had the key, that's fine. So that was one of the major things. Another one was using the data and interpreting it to answer stuff about mean, median, mode, range, and all of that. Some of y'all, when you calculated the mean of this data or you calculated the median of this data, we can calculate the mean right now or the median. So we cross out the lowest, highest, lowest, highest, lowest, highest, right? And now we have these two. For some reason, some of y'all said that the median was 3 plus 4 divided by 2. So you took the average, the mean of these two numbers and divided it by 2, and it would be what, 3.5, right? That's wrong. That is absolutely wrong. This isn't 3 and 4. This is 23. If we look at our key and 24, right? So it is going to be 23 and 24 divided by 2. And the average, okay, of that, the median, okay, is going to be 23.5. That's actually going to be, okay, our median. So I think some of us had a bit of problems with that. Um, so hopefully we can fix that for the test. Frequency table. This goes hand in hand both with dot plots or with histograms. Usually when you make a histogram, you will make a frequency table first, or you'll make it from a frequency table. All it is saying, if we use this dot plot actually as a good guide, how many brothers and sisters does each student have? Well, the number, right, of brothers, okay, or sisters, right? Oh my gosh. Wow, this is awful handwriting. I am so sorry. I have to apologize. Brothers or sisters. Okay, we'll do that. So we have 1 is a possible number, 2 is a possible number, 3 is a possible number, and we keep going until we reach the highest possible number. Okay? And that would be 1 part of our frequency table. Then the other part of our frequency table, after we make our table look nice, the other part of our frequency table is counting how many dots are in each possible value. So there's 1 dot for 1, 1 dot for 2, 3 dots for 3, 4 dots for 3, 1 dot for 5, and 2 dots for 6. Okay, this is how you do frequency table. If you do not write the word frequency, I will take off points. The reason why is because I need to know that you know which data is referring to the frequency. If you don't tell me which one is frequency, maybe you think this right here is frequency. I don't know. It wouldn't make any sense, but I don't know. Okay. So it has it in the name, frequency table. Obviously, you're going to write frequency somewhere. Okay. That was the biggest one I took off points for. If you're able to do that, I think you got your frequency table correct. And then histogram. Okay. So this one, first of all, there's this histogram purposely so. I've already made a couple mistakes. Um, the spaces are not the same, right? Right here versus right here versus right here, not the same amount of space, okay? If this is a continuous number line, right? This is a continuous number line from zero, I don't know, all the way right here. Let's say it's 100, right? I would like to know that these histogram spaces are the exact same, right? So make your histogram even, okay? And then there needs to be no space in between, okay? So a better histogram might look something like this, right? Yay, nice and even, right? But if you put a space in between like this, I'm going to assume that this data right here is a value of zero, that there's no one who had, this many brothers and sisters or could do this many push-ups, right? But if your data, there's no values of zero, there's no space in between where there's no data, then you can't put spaces in between your histogram, okay? So no spaces, no spaces, okay? Those are the four that y'all need to get done on the final exam. I don't think they're that hard. I think these are quite easy, honestly. However, I think if you do not study and you don't practice, and the first time you ever make a histogram is on the final exam, you might get it wrong. You might get some points. And this should be free points and get a 4.0 in Mr. Ryan's math class, right? So just do them, just do a few practice ones before the exam. You have the ones on the test you can do again. You have the study guide that you can do. Um, I think that those are good practice examples. Um, if you haven't done it yet, you should have done the study guide because that was for a grade and it was due almost a month ago. So hopefully we've all done the study guide, but I know you have so many classes. I know it's very easy to forget. Um, I want to say that's everything that has to do with. Oh, the other thing, the final thing is interpreting data. So there'll be questions like this one. How many dots are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's erase this dot. Okay, now there's 10 dots. We should change this 4 to or maybe change that to a 2 for consistency's sake. Okay, now there's 10 dots. You might get a question if this is, let's say this is number of brothers and sisters, right? Number brother slash sister, okay? I want to say what percentage of students have three or more brothers or sisters? Okay, three or more would mean, is it three? Okay, is it four? Is it five? Is it six? It could be all of these possible numbers, right? Three or more, we're gonna include three. Okay. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 8 over the total value, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 80%. So 80% would have three or more brothers and sisters, right? But if I change the question and I say more than three brothers and sisters, hold on. Oh man. All right. So if I change the question, I say more than three brothers and sisters, that does not include three. More than does not include three. Three is not greater than three, right? It's equal to three. So if I say I want greater than three, right? I want greater than three. Well, four is greater than three, right? That's where we start. So you got to read the question. It's testing your ability to understand data in English, right? You got to understand that in English. Okay. I think that's it for statistics. Hopefully that was a good rundown of what was going to be on the final exam. The other part of the final exam is going to be the um dealing with transformations and parallel lines. So let's go over that really quick. Transformations, hopefully super easy. There are four major types of transformations, okay? So there's translation. So translation is when I have a figure and all it does is it slides, okay? Okay, well, if I could draw it. Right? And I have slideshows uploaded on Google Classroom for all of this, so you can go see yourself. That's another thing you should study. You have the test, you have the study guide, you have slideshows on Google Classroom, you have previous homework. So you don't have previous homework on this unit, but you do have previous homework on statistics and you have slideshows for everything. So if the test and study guide aren't enough, you also have slideshows that I've uploaded. I think you have plenty of test material to study. So this is translation, okay? Translation. And the way that Mr. Ryan, remembers this is I see an S in translation and I think slide, right? I think slide, translation, okay? Translation. Then we have rotation. Now, rotation, if I have the same triangle, now let's do reflection next. JK, just kidding. Reflection. I'll just draw a line. That'd be faster. Reflection would be what happened to the triangle? Oh, well, it's not drawn correctly. That's what happened. Uh, all right. We'll pretend that's good enough, I guess. It's not really, but reflection is like a mirror, okay? Reflection is going to be the figure reflected across the y-axis, x-axis, one of the two. Reflection. It reflects. You're going to be expected to be able to look at a picture and tell me what is going on. Okay? Translation, reflection. All right, then the other one, right? Let's say I have, this figure. Okay. And then here is the center that it's going to rotate up on. Actually, it'd be easier as if I'd rather. Mm, I'd rather not be confused with. Yeah, that'd be better. Okay. Not a perfect triangle. In fact, it's still bothering me, so I'm going to change it just slightly. All right. Thank you for being patient. All right. So let's say I had this triangle right here and it rotated from here to here. That is rotation, okay? These are the big major three, okay, that you're going to need to know. There's one more, actually. Rotation. Okay. So you need to be able to look at a figure and tell me what's going on. And obviously, the pictures on the exam are going to look a lot better than the ones that I just drew here. So you don't need to worry about that. The other one that you're going to need to know is dilation. Now, the reason why this one is a little bit separate from the others, dilation. Wait, I think, yeah, I did not spell that right. I'm a math teacher, not a English teacher. Dilation. All right. So the reason why I think this one's a little bit special is because you could have a translation, right? And a dilation occur. Now, I'm not going to be mean and say, did a rotation and reflection and translation occur? Tell me if all three occurred, right? I'm going to be a little mean though. And I might say you need to tell me if both a reflection and dilation occurred, or a rotation and dilation occurred, right? Or just one of the two. Like, I want you to tell me what occurred here. So right here, it's a translation and a dilation, right? Went from small to big, and it moved positions. It slides. So I think that might be hint, hint, good to keep in the back of your head for whenever you take the exam. The other thing that is going to be on the exam that we went over recently, um, are parallel lines, right? And so if I have, right, two lines and there is a arrow going through them like this, that means despite how terrible the drawing is, that they are parallel. And then I have a line that goes through them, and this is, 110 to 115 degrees, right? That means this one is also 115 degrees, right? Right here is also 115 degrees. All right, and then what would that make this right here? It'd make it 65 degrees. It'd make this 65 degrees, right? And so on and so forth. All right, I don't think I need to write it for every single one. Okay, I think you get the idea. And it's 65 degrees because it's 180 minus 115, right? It's going to be the leftover of the 180 degrees that a line would create, right? Um, Knowing that information is all you technically need to know to be able to answer everything on the test. However, I do think that you should do the practice problems that we did in our notes that are going to be in the slideshows uploaded on the Google Classroom. And I will have a like final one-page worksheet of new practice problems that I can give you for the final exam. So you have your study guide for Unit 6 study. You have your study guide for Unit 6 statistics, and then you'll have one extra worksheet, which would act as a study guide for um, the parallel lines and transformations. That will deal with triangles. It will deal with um, finding missing angles of figures. I don't think they're terribly difficult, but I would not, in my opinion, wait until the final exam to be the first time that you try those practice problems. So that is everything that's going to be on the exam. If that's all you care about, then awesome. Thank you for tuning in. I appreciate you. However, I do know that In Mr. Dong Wong's class, you guys are going over graphing quadratic equations. And that is something that we do in M3. It is something that I have taught my M3 students. Um, and I would love to take this opportunity, if you do not know how to do that, or if you're confused, to go through graphing quadratic equations boot camp. Okay. So I'm going to pull up. Hmm, actually, let's pull that up. Okay. So let's go over how to do it very quickly, okay? For the last, I think, 15 minutes that I have here. So let's see. Here's what we're gonna do. Yeah, I guess we'll just do that. So let's say, oh no, not highlighter. Okay, let's say I have this quadratic equation, x squared minus 2x minus 4. Okay, and I want to know how to graph this quadratic equation. Okay, here's what we're going to do. Step one, okay? 3 steps. Step one is find, okay, axis of symmetry. Now, this is a fancy word, and I'll tell you what it means. Axis, oh gosh, I gotta go fast if I want to fit this in. It's okay if it goes over a little bit. Axis should be of symmetry. Darn it. Axis of symmetry. All right. Now, what does that mean? It means when I graph a quadratic equation is this. It means it has the square right here. When you see x squared, you're dealing with a quadratic equation, okay? That's what quadratic equation means. So when I have a quadratic equation, okay, and it's gonna look something like this. Whoa, cool. Yay. Best day ever. Got my graph. If I were to, actually, yeah, if I were to fold this quadratic equation in half, right down the middle, it would be the same on one side and the same on the other, right? Kind of like this piece of tissue, this napkin right here. If I were to fold it, okay, nice and even, it's the exact same on one side and the exact same on the other, right? There is a invisible line that runs in the middle. That's called your axis of symmetry. Symmetry means like the same, okay? So there's an invisible line. Now, this is on the x-axis, okay? So that's x, this is y. That means that, okay, y could be 10 right here. Y could be 5 right here. Y could be negative 10 right here. But x is always this blue line right here. X does not change. Y is the thing that changes on this blue line. Y can be any number, but X is always -4 or whatever the number is here for the axis of symmetry, right? If you don't quite understand that, that's okay. As long as you follow these steps, you should get it right. So that's an example. The formula for axis symmetry has to be the same, always. X equals negative b divided by 2a. And if you don't want to listen to this part, you can tune it out. But for my nerds, this comes from the quadratic formula. Negative b plus or minus. That is a terrible plus or minus. Plus or minus the square root of b squared minus 4ac all divided by 2a. Right? If you haven't seen this yet in your math career, you will in M3. And if you have seen this in your math career, awesome, right? This negative b over 2a is where our axis of symmetry comes from. That's where it comes from in the formula, right? So pretty neat. Cool stuff. These things really do connect. So in this situation, okay, I have, now would be a good time. If you don't know where B and A come from, if you're like, what the heck, where do B and A come from? Well, we have AX squared. This is the form that every quadratic equation has. AX squared plus BX plus C. Okay, every quadratic equation has this form. The only thing that needs to be true is A has to be a number that is not equal to 0. Because then if this equals 0, there is no x squared, right? Um, in this situation, okay, A right here is 1, right? A equals 1. It's like an invisible 1, right? B right here is not 2. If you put 2, you go to math jail, okay? For a very long time, you go to math jail if you put 2. It is negative 2, right? Same for C. C in this situation is going to equal a negative 4. Okay. So when I look at my formula, X, okay? So we have X equals negative B. Every time I see a letter, I'm going to put a bracket or a parentheses, okay? I don't want to mess anything up. Negative B divided by 2 and then another bracket, okay? Now where I see my brackets, that's where I fill in my letters. So I have a negative 2 for B, and then I have a 1 for A. So it's going to be a negative 2. That means it's a positive 2 divided by 2. Okay? And all of this is going to equal 1. Awesome. I've done step 1. I've got my axis of symmetry. X equals 1. X equals 1. What that means is I can erase this picture because it's not true. Okay? But at X equals 1, if we go on our number line right here, if this is 0 and X is 1 right here, at X equals 1, there is an invisible line, right? Whoa, invisible line. That the graph of this equation, x squared minus 2x minus 4, is going to center around, right? That's what x equals 1 is saying. So we have x equals 1, okay? Step 2, okay? Create function table. Step 2 is function table. What is a function table? Well, a function table is when we put numbers in for x and then we get out numbers for y. So we choose what x numbers there are. So we're going to draw a table, okay? We're going to draw a better table. I swear, there's like probably have like 10 minutes of me just complaining about how bad I'm drawing. All right. Okay, actually we can do. So we have values x and y, right? We have x value and then we have our y value, okay? Now, in the middle of your function table, why did we do axis of symmetry? Why the heck did we do that? Well, we did that because that's going to be the center. So we put a 1 right here for x. We know x is going to have 1 right in the center. And then we do 2 before it, 0 and -1. And then we do 2 after it, 2 and 3. Now what we do is we put our x values back into the original equation. So I'm going to write, okay, off to the side, I'm going to write, um, sorry, how do I do this? Okay, there you go. Do I have the right color? There you go. Okay. I'm going to write, okay, not x squared, but I'm going to write a number in there, -2. Again, not x. I'm going to write a number in there, -4. Okay, so instead of x, I'm going to use my axis of symmetry. 1 squared, -2 times 1, -4. So 1 squared is 1, minus a 2, minus a 4. So that is going to be -1. So it's going to be 1 minus 2 plus a negative plus a negative. So it's going to be -5. So that means that I'm going to put -5 right here. Okay. And then instead of 1, I'm going to change it now. And I'm going to do 0. Okay. And we're going to do this for all the numbers. Okay. If I put 0 in, we're just going to get -4, right? Because 0 squared is 0. -2 times 0 is 0. And then we're just going to get, I don't like this being right here. All right. And then we're just going to get -4. Okay. If this were in class, I don't think I'd be moving this fast. I'd be going a little bit slower, but I'm trying to hurry up the recording. Um, okay. And then I can change this 0 and put a -1. Okay. So -1 squared is a +1, but -2 times a -1 is a +2, right? And then we have -4. So this is all going to equal a -1 as well. Okay. Now, here's the crazy part. These values right here, okay, for the other half, this one and this one, they're going to match and mirror these values. Well, what do I mean? I mean that if I put 2 in, I promise you I'm going to get -4. If I put 3 in, I promise you I'm going to get -1. Don't believe me? Let's try. All right. We're going to put in 2 for this equation. So I have 2 squared -2 times 2 -4. 2 squared is 4 -4. Whoa, and then -4. So it's going to be -4. Whoa, it's the same, right? They mirror each other. Okay? So these all mirror each other. The last step, step three, okay? Step three is graph. That's it. So now I have my ordered pairs. What does that mean? That means that I have X and then I have Y, right? I do X first and then I do Y. So I'll do one and then negative one and then negative one, right? So negative one here and then go down to negative one. Okay. Then I have 0 and negative 4, negative 1, negative 2, negative 3, negative 4, right? Obviously, you would do it much better than this. I'm just trying to go through it fast. Then we have 1 and then all the way down to negative 5, right? Then we have 2 and we go to negative 4. Then we have 3 and then we go to negative 1. Now, if you're looking at this and you're like, "Oh my gosh, Mr. Ryan, how did you just graph all of that? There's no way I can do that. I have no idea how to do that." Oh my gosh. Sorry, I'm trying to concentrate. Can't draw it. Okay. Oh, that's not that bad. Oh, that's actually pretty good, except my axis symmetry looks bad, but whatever. Okay, we'll get rid of the axis symmetry. Yay, we graphed it. Okay, maybe not to scale, but we graphed it. Now, if you're saying, "Mr. Ryan, there's no way I can graph those ordered pairs. As soon as you did the dots, you lost me." I promise you it's not as bad. You just need to do many examples. Okay? You need to do the same example over and over and over and over again. As soon as you do one example, flip your page, do that exact same example, and see if you can recreate your answer. That's my recommendation, okay? Do it with a tutor or with a teacher first, and then do it on your own, and then go back to that same tutor and teacher and say, "Hey, I did this on my own. Did I do it correct?" And repeat the problem like 3 or 4 times. That's how you learn something. That's how you get good at something. I hope this was helpful. Um, I'm not sure if this last part is something that is going to be on a supplemental final exam or part of homework or anything like that. I just personally believe it's very important to learn for M3. And I think it's also in one of your other math classes. So here's the opportunity. I finished my lesson early for my final exam. So I wanted to add a little something. Hopefully, I didn't hurt your brain too much with this. All right. Thank you so much for paying attention, for watching. I wish everyone good luck on their exams. I always say work hard, play hard. That means that you study, you're not going to have a fun time. You are going to concentrate for the whole week, and it's going to be terrible. But then when you're done and you got all your exams done, then you get to play. Then you get to go play video games. Then you get to go spend time with your friends. Then you get to have a bunch of fun. You work hard, then you play hard. That's my belief. So I hope you take on that belief too, and I hope everyone does a great job on their exam. Thank you so much. See y'all.